In this video, we're going to construct a vernier scale. Here is a vernier slide caliper, and it has a main scale as well as vernier scales, one here and one on the top, and they're on a slide. So we're going to construct one of these using a main scale and a vernier scale connected to the main scale in this video. So consider this word problem. It says here, design a vernier scale that subdivides the main scale into divisions of size 5/1000 of 1 inch. The smallest scale division on the main scale is to be 0.025 inches. So I don't have a main scale here. I'm going to draw one, and I'm going to draw one using a ruler without any divisions on it whatsoever. So I'm going to make my own divisions. So here we go. We'll just draw a line. That's just for the sole purpose of drawing a line right here. Let's see. Let's start here. And I'll just draw a straight line. And I'll end somewhere here. Put that straight at your way. It says here, the smallest scale division on the main scale is to be 25/1000 of 1 inch. So we'll call this the main scale. And we're going to draw some increments on here. And each increment is going to have a value of 25/1000 of 1 inch. So let's see, we'll go to here. This is not exactly 25/1000 of 1 inch, but it's a representation of that, so I can show you how to build the vernier. So from there to there, we'll call that a distance of 25/1000 of 1 inch. This is 0, and that first increment will be 0.02 25/1000 of 1 inch. And we'll repeat that increment. And I'm doing this freehand. We could use a scale or ruler or something in order to make it more even, but I'll just do this freehand. We'll put one here, and I'll put one here, and I'll put one here, and about here, there, and I'm trying to just space them evenly as best I can. Now let's give them some numbers. If each one of these is 25/1000 of 1 inch, that will make this one here 0.050,000 of 1 inch. This one here will be 0.075,000 of 1 inch, 25, 50, 75, making this one, being careful, watching that decimal place, this will be 0.100 inches or 100 thou. Then this increment here will be 125 in increments of 25,000, 125, this will be 150 thou. 175, 5 thou, and 200 thou point. And of course this here will be 225, that looks a little long. So I'll make this one a little bit shorter. 250, 275, and we'll stop here at 300 thou. So each one of these now has, each one of these increments has a value of 25/1000 of 1 inch, or the discrimination on this scale which I have drawn is 25/1000 of 1 inch. Obviously it's not to scale to the 25 thou increments, but it's just a representation. And then it says here, in order for us to build a vernier scale, design a vernier scale that subdivides the main scale divisions into 5/1000 of 1 inch. And what that is telling me is take one of these increments from 0 to 25 and divide it into 5/1000 of 1 inch. So how many subdivisions do I need to divide this into in order to make each one value of 5 thou? So calculate the number of subdivisions needed in order to make each one of them a value of 5/1000. And we'll do that by taking the original length, 25 thou, divide that by each increment we want to be 5/1000 of an inch. The inches cancel out, and that gives us a total number of 5 without any units that mention this number. And that means we have to divide that segment into 5 even units, and each one will have a value of 5,000ths of 1 inch. Well, let's do that over here. I'm going to reproduce this up here. There's 0. There is 25,000ths of 1 inch. And I just calculate I have to divide that into 5 even segments. Oh, 1, 2, 3, 4. 1, 2, 3, 4, 5 even segments. Each one of them ought to have a value of 5,000ths of 1 inch. From there to there should be 0.005. So that's 5, 10, 15, 20, 25,000ths of 1 inch. So basically I've divided this segment into 5 smaller segments, each one a value of 5 thou. I just didn't do it here. I could put them on here. 1, 2, 3, 4, and that'll be 5. So each one of these now is 0.005, 5, 10, 15, 20, 25. But they're small and they're all crammed in together. What the Vernier scale does, Vernier, it takes this little bit and expands it. So considering this up here, if I were to make this line here the 0 and expand it, make it way over here, so 1, 2, 3, 4, 5. And this line here would be 0.025. So I've taken that segment, made it bigger, and this will be the Vernier. That's what the Vernier does. It takes something small and amplifies it. This is called amplification. So we can see the little itsy bitsy segments a little better. And let's do that here now. So we're going to make a Vernier scale and attach it to this main scale. To do that, we need to, let me write this down first, make Vernier scale. A length of that number 5 of 5 units. That's the number we're going to take. Make a length of 5 units less 1 unit on the main scale. Or maybe I ought to write that less units with respect to the main scale. That sounds better. So make a Vernier scale of a length of 5 units less 1 unit with respect to the main scale. So let's make a Vernier scale. I'm going to use this other piece of paper here to represent the slide that you saw earlier, so that I can slide it back and forth. So I'm going to draw the Vernier here. And they're both going to start at 0. Here's my 0. This is going to be my Vernier scale. And this one above here, well, that's the main scale. And my calculation says here I need to divide it into 5 units. I'm going to use this in order to count 5 individual units on the main scale. 1, 2, 3, 4, 5. The original 25 thou increments, not these little ones. So that was my first line. 1, 2, 3, 4, 5, less 1. Less 1. So that'll be 4 main scale units, and that's going to be the length of my Vernier scale. 1, 2, 3, 4, right here. And the value of this line right here, because I'm trying to represent here from 0 to 25 thou, I'm going to put it here on the Vernier scale. So this is 0, and that 25 thou will be here. 0.025 thou, that'll be the value of this line. I need now to divide this into 5 even segments, such that each one has a value of 5,000ths of 1 inch. And I'm going to move this down here away from that scale because it sort of gives me a little bit of bias. Try to divide this as evenly as I can into 5 segments. And let's see, 1, 2, 3, 4, that's about right. 1, 2, 4, 5. 1, 2, 3, 4, 5. And each one of these now has a value of 25 thousandths of, 5 thousandths of 1 inch. If this one is from there is 5, this is 10, 15, 20, 25. Putting this vernier scale back onto the main scale, reconnecting it here. And the way we built this, we used 4 main scale units, 1, 2, 3, 4, in order to build the vernier scale. And then we divided it into 5 even segments. That's what we calculated here. So it's this number minus 1, gives us the number of main scale units to give us the total length of the vernier scale. And then we divide it by the same number that we calculated, divide it into 5 units. And now we have what's known as a vernier scale. And what this vernier scale does, it takes this segment between 0 and 25 thou, and all of these little guys in between, takes these little guys in between and stretches them out along this length from 0 to 25, like I showed you here. And this is called amplification. Now to use this vernier scale, and my increments here are not evenly spaced, but if this were the vernier caliper, here is a vernier caliper, and there's my main scale. Here's my main scale right here. And here's the sliding caliper, the vernier, which we just made. So I'm going to slide it back and forth in order to make a measurement. We're going to read what's on the main scale, and then we're going to read the vernier scale. And in my little representation, this will be 0, 0. You just take the caliper and go 0. Everything is 0. There's the 0 and 0 on the main scale and on the vernier. And if I make a measurement, the vernier is going to slide. And let's see, I'm just going to slide over to about here. And then we make a measurement. To make this measurement, we're going to read all of the values on the main scale. Remember, these are not on the main scale. So I've transferred these to the vernier. So on the main scale, all of the values prior to the 0, I have 25 thou, 50, 75, 100 thou, and the 0 is somewhere between 100 and 125. I can take a guess, but that's not the idea of metrology. We don't like to guess like this, so we're going to use the vernier scale to determine what this value here is. We do that by looking at the lines that line up. Which one of these lines best lines up with the lines here on the main scale? So which one of the lines here on the vernier caliper best line up with the vernier scale, I should say, best line up with the main scale? Not that one, not that one. This one's pretty close. Not that one, obviously not that one. So I have to go with this one. So writing this stuff down of 25, 50, 75, 100 thou, 0.100 on the main scale. Plus what the values that we read on the vernier scale, the one that lines up the most is this one. And the vernier scale is in increments of 5 thou, so it's 5, 10, 15 thousandths of 1 inch. So we're going to add to it 15 thousandths of 1 inch. 0.01, 15 thousandths of 1 inch. Therefore, this whole length is 115 thou. So it's somewhere between 125. And in my demonstration here, it's 115 thousandths of 1 inch. That will be the measurement being made using this specific scale. And this is the making of a vernier scale, I should say.